Video, we've got quite a tricky proof by induction question. So we're going to look at this by thinking about how Dijkstra works at the time. So we have our set of finalized vertices, which we will put here. So we'll call this Q. We've got this vertex U over here, and we've got a vertex V, which is being added to Q, and we can see that that is the next one that we would add. So first thing we do, and this is any exam we want to get our easy mark, is think of our proof by contradiction statement. So we're saying the thing we're trying to prove is that there cannot be a shorter path to node Q. So suppose there is a shorter path to node V. Now we've got to think about where that path would need to go. So it would have to go from S. Let's do this in another color. So we go from S, some other vertex, let's say W, inside Q, and that would then go to another vertex on the outside here, and that would take us to V. So let's analyze this path. Is it possible for that green path to be shorter than, let's just highlight the path we were going to originally take, than this one? Well, we know that, so going to V via W, which is inside Q, and X, which is outside Q. Now, let's first think about how Dijkstra works. So when we decided to add node V, we did it because it was the shortest distance of all the unfinalized nodes. So that means that the distance from S to X must be greater than the distance from S to V. There we go. So the distance must be at least as great if we go via this shortest path from S to X. And then we've got to consider the remainder from X to V. Well, we're assuming these are all non-negative edges, so then we know that is at least 0. So it's greater than or equal to 0. I mean, it's a bit of a mean one, but we know that Dijkstra only guarantees a solution when we have all positive edges, so it's not an unreasonable assumption to make. And so, I mean, just using sort of maths of inequalities, that means the path from S to W to X to V must be at least as great as the path from S to V, which Dijkstra found. And then we say, hence, that's contradiction. Hence, contradiction. So no shorter path exists. There. Now you might be thinking, why do we need to have a node X outside of the finalized vertices? I suppose technically we don't, but if there were two edges from Q to V, both with that same minimum weight, we could pick either of them and they would have that minimum weight of, in this case, 5. It wouldn't be less, or at the point of choosing, we would already have reduced. I mean, you can see that in the process of doing Dijkstra, I reduced the weight of V from 6 to 5. We would have done that as much as possible already. So there would be no shorter node, no shorter route from Q directly to V. So on these questions, they are pretty hard. Key thing, I reckon, the 1 mark everyone should be able to get, although it's not trivial, is to get that initial contradiction statement. So make sure that we effectively say what is the contradiction to our thing, and spend some time thinking about it, because it's quite easy to get that wrong as well. And then try and do a concrete example, do a little sketch and think about how the thing works step by step, and that should hopefully lead you to an answer.